Hello everyone, my name is Visvajeet. Today I am going to show you the implementation of serial communication using UART0. Now let's see. Now let's start with the what is LPC2148. For this we are using LPC2148 microcontroller, which is designed by Philips Tech NXP Semiconductor. It belongs to ARM7 family. This is the specification of this. Now let's continue. Now what is UART0? UART0 is the first UART, that means Universal Asynchronous Receiver Transmitter, on LPC2148. It is a hardware communication protocol that allows two devices to communicate with each other over a serial communication. Basically, in UART, we transmit or transfer the data serially, bit by bit at a time. So UART0 has variety of purposes. UART0 protocol consists of uh, totally of 10 bits, in which first bit is start bit, then 8 data bits, and last one is the stop bit. The stop bit is also start bit is always low, and the data bit can either be high or low. The stop bit is always high. Now in UART0 register, we have to configure UART0 protocol. The UART0 LCR register is used to configure data format. U0, DLL, and DLM are used to configure the baud rate for which data is serially transmitted, and U0 IER register is used to enable or disable interrupt. Now these are the registers available in the UART0, that is U0 LCR, U0 DLL, U0 DLM, U0 IER, U0 IIR, U0 FCR, U0 LSR, and U0 MSR. These are the registers available. Now we will use them one by one. Now this is the code which is for the UART0 implementation. Now let's see. Here we have included the LPC2148 library, and then we have prototyped one function, and then we have created one variable temp, then flag and initialized it to 0. Now UART0, for this we have to use pin select 0. That means that is from 0 to pin number 15, and we have assigned it with the value of 5, because for NXP UART0 we have to use pin number 19 and 21, that is P0.0 and P0.1, and to configure that we have to configure it with the 8-bit of dataset, and that value is comes out to be 5. Now we have IO0 DIR, which is used to make this as a high for data output line. Now we have used U0 LCR. U0 LCR is basically line control register, and for that we have to configure. For that we have considered 8-bit data, in which 7th one is DLAM. Now for U0 LCR, starting value should be the last 0 and 1. 0, 1 represent the word set, or we can say how much data to be transferred. For example, for this we have to create 8-bit. For that 0 and 1 should be 1 1. The bits 0 and 1 should be 1 1. Next comes the stop bit, that we have not to consider, so we will put 0. Next comes parity enable. We also don't require this one. 4 and 5 are for parity select. This is also not required. Now here comes the 6, which is break control. That one is also 0. Now here comes the important, that is DLAB. DLAB should be 1 starting, so that by making DLAB 1, it comes out to be 0x83. Now 0x83, this by making this will allow the register to, U0 DLL and U0 DLM to enable, and by this we can set the baud rate, that is U0 DLM and U0 DLL. Now after setting the baud rate, we have to make the DLAB value as 0. By making DLAB value as 0, now here comes the value U0x03. By making this, now we will enable transmitter and receiver interrupt, and by making this we have two more register, that is U0 THR and U0 RBL, that is transmitter and receiver get enabled. Now we have created one vector address 0 and sign the value, then vector enable we have enabled, then we have created RX and TX flags, and then we have considered the conditions for flag to be raised high, and that's it. Now this is the main loop in which we have used U0 IIR, that is interrupt enable register, and stored in value temp. Now we have checked the value of temp, which comes out to be from the transmitter, which is get it in stored in temp, and that is checked with the 0x002 If it satisfies, then transmitter flag is raised high and vector address variable becomes 0. Or else, the if value is matched with 0x04, then transmitter and receiver will be register will be equal and receiver flags raised high and vector register address will be 0. Now this is the implementation in we can say ARM processor, Key Microvision U5. This is the code. Now you can see. Now we have written the code and build it. Now we will use Flash Magic so that we can implement or see the output. Now we will select UART hex file over. Now it is loading. Now let's wait until it's finished. Now as you can see, it is finished. Now I will click into tools. Now comes terminal. Now terminal. This is the main terminal input and output. By this, let's first clear it. Now after clearing it, we have seen this is the input and this is the output terminal. Input and output. Now whatever we will write from the keyboard it will be act as an interrupt. Now interrupt. So whenever we press any key, it will be transmitted one by one, bit by bit. Now whatever we write in input, that will be visible in the output screen. Now let's see. For example, I have written WIN, that is win. Now you can see I have written win and it is displaying on the output screen. This by this we can say this is the clear implementation of UART0 serial communication. Thank you. Have a nice day.